Today's lesson is on the Pythagorean theorem and its converse. Our learning target is to be able to use the Pythagorean theorem and its converse to solve problems involving triangles. I'm going to assume you can write yourself an essential question based on the target. So here we go. A set of three positive integers, a, b, and c, that satisfy the equation c squared equals a squared plus b squared is called a Pythagorean triple. Pythagorean triple. A set of three non-zero integers that satisfies the Pythagorean theorem. And guys, I'm going to tell you, you must memorize these Pythagorean triples that are the common ones. For instance, 3, 4, 5. What else do we have? 5, 12, 13. And there are some others. You will see a list of them in your book, and I did encourage you to make a flashcard with the most common Pythagorean triples. Alrighty, so let's talk about the Pythagorean theorem, which you all learned many, many years ago. And here we go. It says in a right triangle, the square of the length of the hypotenuse is equal to the sum of the squares of the lengths of the legs of the triangle. And of course, we've always known that as a squared plus b squared equals c squared, with of course c being the hypotenuse. Okay, that's the Pythagorean theorem. You've always known this part, but maybe you didn't know the words, so there you go. All right, so what is the converse? Well, of course, the converse is going to say that if we got a triangle, and we know that the square of one side is equal to the sum of the squares of the two other legs, then we're going to be able to say it's a right triangle. So if the square of the length of the longest side of a triangle is equal to the sum of the squares of the lengths of the other two sides, then the triangle is a right triangle. So that's the converse. So if a squared plus b squared equals c squared, then triangle ABC is a right triangle. All right, and of course you would have to be able to use both of those theorems, the theorem and its converse, as a reason in a proof. All right, now we've got some other theorems that tell us some things, whether we have an acute triangle or an obtuse triangle based on the length of the sides. So this acute triangles theorem says if the square of the length of the longest side of a triangle is less than the sum of the squares of the lengths of the other two sides, then the triangle is acute. All right, and if I want to write that in an inequality notation, what I know is that if c squared is less than a squared plus b squared, then triangle ABC is acute. It's a cute little triangle if c squared is less. So maybe when you think of acute, when you think of the word acute, you know that that's small, right? It's smaller than 90 degrees. So maybe you can think of acute, if an acute angle is less than 90 degrees, maybe that will help you to remember these two relationships. If c squared is less than a squared plus b squared, then the triangle has to be acute. All right. So now I think it stands to reason that if the square of the length of the longest side of the triangle is greater than the sum of the squares of the lengths of the other two sides, then the triangle must be obtuse. And if you think about it, as this side here C, as this side C gets longer and longer, then that angle C is going to get larger and larger. So try to think of it that way if you're having trouble remembering. All right, so if c squared is greater than a squared plus b squared, then triangle ABC has to be obtuse. Okay, so let's do some practice. Find the missing link. Okay, we got a right triangle here. We got a right triangle, so we know right away that a squared plus b squared equals c squared. because it's a right triangle, do the side lengths form a Pythagorean triple? Well, how are we going to figure that out? We're going to do 24 squared plus x squared, and we need to know if that equals 25 squared. All right, so x squared equals 25 squared minus 24 squared. All right, so x squared is 625 minus 576. So x squared is 49. So remember, when I solve this by taking the square root of both sides, I'm going to get x equals plus or minus 7. But of course, x can't equal negative 7 because we're talking about the side length of a triangle. So x equals 7. So is that a Pythagorean triple? Yes, it is. So let's look at this one. All right, we got 8 squared plus x squared. Whoops, sorry about that. X squared is the hypotenuse. So does 8 squared plus 15 squared equal x squared? We'll see if it's a triple. So let's see what we got here. We got 64 plus 225. I guess I took too much room up doing this one. So we'll try to squeeze it in here. I know since you're at home, you're probably using your calculator anyway. So let me just come down here a little bit. So this gives us 9, 8, 289. And is 289 a perfect square? X is going to be plus or minus 17. So yes, indeed, once again, these are Pythagorean triples. And of course, we know we got to eliminate the negative sign here because it can only be a positive length since it is a length aside of a triangle. Okay. Remember that the formula for finding the area of a triangle. Remember we had this on our last test. Some of you did not remember. Formula for finding the area is 1/2 base times height. All right, so let's find the area of the triangles to the nearest tenth. All right, so what do we got to do here? Well, h is our height, right? H is our height, so we've got to find out what h is, okay? And since this is an isosceles triangle, you remember what the altitude does? It bisects the base. So I know that this is 9 and this is 9. So the best thing I could do would be to try to figure out if this would be a triple. Now, if the side lengths, let's say we take the triple 3, 4, 5. If I multiply all these side lengths by the same number, for instance, if I multiply each one of these by 2, 6, 8, 10, that would also be a triple. I can multiply these numbers by any number, and if they all remain integers, then it's a triple, but I don't think that's the case here. So what we have to do is we have to figure out what h is. So I know that h squared plus 9 squared equals 12 squared. So h squared is 144 minus 81. So h squared is going to be, that'll be 63. So h is plus or minus the square root of 63. Well, we know we're going to get rid of the negative. So guys, for the time being, as long as we're talking about triangle side lengths, I'm not going to find the negative answer, but just remember, if we're not talking about lengths, you have to have a plus and a minus. So h is going to give us here, we got a perfect square in there, 9. 9 times 7, so that'll be 3 times the square root of 7, and we're talking about inches here. All right. Oh, not too fast. I'm looking for the area. That's just the height. I was about ready to draw a box around it. So what is the area? So if h is 3 times the square root of 7, and I'm going to assume I want the area of this triangle, this entire triangle. So 1/2 The base is 18. The height is 3 times the square root of 7. That's going to be 9 times 3 times the square root of 7. So that's going to be 27 times the square root of 7. And what do the units always have to be for area? Square units. So that'll be inches squared. 27 times the square root of 7 inches squared. Now we're going to classify these triangles as right, acute, or obtuse. How are we going to do that? Well, let's remind ourselves. If c squared equals a squared plus b squared, of course we know that's a right triangle. If c squared is less than a squared plus b squared, we know that that's an acute triangle. And if c squared is greater than a squared plus b squared, then we know that that's an obtuse triangle. I know this first one here, definitely not a triple. This one is possibly a triple. Why? Because these are all integers. The side lengths are all integers, so maybe that's a triple. I don't think so. This one, definitely not a triple. What should I do? Maybe I should make sure that they actually form triangles first, right? The sum of the side lengths of any two sides has to be greater than the third side. I do believe that is the case for all these. So let's just go ahead and start. Let's do this. This looks like the longest side, 8 times the square root of 15. So let's do 8 times the square root of 6 squared plus 24 squared. And then c squared. This is a squared, b squared. So c squared is going to be 8 times the square root of 15 squared. All right, so what does this give us here? 64 times 6, 384. 24 squared is 576. 8 times the square root of 15 squared is 960. So let's see, if I add 384, 0, 1, 6, 1, 9. So they're equal, so that means this is a right triangle. That's a right triangle because a squared plus b squared equals c squared. All right, let's try this one. 33 squared plus 56 squared. That's a squared, b squared, c squared, 65 squared. So let's see what we got here. 33 squared. 33 squared is 1,089. 56 squared, 3136. And c squared is 4225. So let's see. If I add these two together, I get 4225, 4225. So again, I got another right triangle. All right, let's do this one here. 2 times the square root of 38 squared plus 10 squared is a squared plus b squared, and then c squared, 16 squared. So let's see what we got. 4 times 38, 152, plus 100. And what is 16 squared? 256. So what do I have here? I've got 252, and c squared is 256. And c squared is greater than a squared plus b squared. So what does that mean? It means I've got an obtuse triangle right here. So this is right, and this one is obtuse. Okie dokie. All right, and finally, can the numbers that we have here represent the side lengths of a triangle? If so, classify the triangle as right, acute, or obtuse. Well, how do I decide if the lengths can represent the side of a triangle? Well, first I have to make sure that the sum of any two is greater than the third one. We definitely have, this definitely is a triangle, because I can see if I add any two of these that they're going to be greater than the third one. So yes, it's a triangle. So now I have to do a squared plus b squared and then c squared. So I got 5.7 squared plus 12.2 squared and 13.9 squared. And of course you would have to use your calculator for this since you have a decimal. And what do we get when we do all this? We get 181.33. And here I get 193.21. So c squared is greater than a squared plus b squared. Therefore, this one is obtuse. Obtuse triangle. Okay. Now let's see what we have here. Let's first we want to decide if it's even a triangle. 28 plus 40 is 68, definitely greater than that. So yes, definitely is a triangle. So let's see, could this be a Pythagorean triple? What goes into all these? 4 does, right? 7, 10, 12. No, that's not one of our Pythagorean triples. So I'm left with, once again, finding a squared plus b squared and then c squared. So 28 squared plus 40 squared, and then c squared is going to be 48 squared. So if I add these two, 28 squared plus 40 squared, I get 2384, and c squared is 2304. So a squared plus b squared is greater than c squared, which means I have an acute triangle. Acute triangle for this one. All right, once again, if I add any two sides, the sum is greater than the third side, so I know this is a triangle. 2 will go into all these, 8, 15, and 17. Let's see, if 2 goes into this, 8, 15, 17. By golly, I think that's a Pythagorean triple, but let's make sure. What's a squared plus b squared? A squared plus b squared, 16 squared plus 30 squared. It's 1156. C squared is 34 squared, which is 1156. So yeah, that's a right triangle because this is a triple. Memorize it. Don't forget it. Pythagorean triple right there. Save yourself a lot of time on your test and quiz if you memorize these. If you don't, you might run out of time. So this is a right triangle. And finally, one more. It's not a triple. Not a triple. Let's see. Oh, it's not even possible, right? Because 8 plus 13 is 21, and the sum of these two side lengths is less than the third side, so this is not even possible. Not possible. All right, you guys need to write yourself a summary, and you need to start doing a little bit better job with your summaries. Don't just say I learned about the Pythagorean theorem today. You need to write a summary that's going to help you remember exactly what you did and how you can use not only the Pythagorean theorem, but these other theorems as well to solve right triangles and to decide whether you have a right triangle, an acute triangle, or an obtuse triangle. Thank you.